Hello everybody, Dave Shopius here. Welcome to my robot lab. Today I'm going to be hooking up my radar on this B9 that I'm repairing for a friend that sent it to me because it needed some love and attention. I'm animating this robot and I've showed you in another video how I set up all the gears and made it move and installed the motor. But what I want to do now is wire in this Sabertooth. Sorry, I lost it there for a minute. That Sabertooth along with that little Kangaroo daughter board that's attached to it. By itself, the Sabertooth cannot command position and speed. It needs a a Kangaroo daughter board hooked up to it, made by the same company, that gets information from either limit switches, a potentiometer, and various other little things. So I'll explain that as I go along, okay? I'm going to take this apart so I can explain it to you, and I'll be right back. Don't go away. More to come. Alrighty then, I'm back. And here is the head section of my B9 that I'm working on. It's upside down. I had to take the bubble off and the crown and everything. So there's the crown and the lid. So we could take a look at the inside here really quick. But what I have here, pardon me, is simply, and I showed this in another video, and I've got it all wired up now, but I mounted this motor with the gear set on it. Down there you can see it spin as I turn it. It has an encoder on the end, and that's what we need to get that Kangaroo some information about where this thing's at and what speed it's heading, so we know how to control it. This is the really quick. This is the connections going up into the brain, and it's just power right now because all the brains are in the brain. So I showed that in a different video too. We're not going to get into that today. So what we have here, I have actually two leads, and you can see this ribbon cable off here. I spliced into it with wires up underneath this corrugated covering, and I split it, and I have two connections, one for power that the encoder and that the motor is going to need. So this is motor power that the Sabertooth is going to command back and forth at different speeds. This is the feed down to the Kangaroo from the encoder, and in that I have encoder power because that needs power too, and I have a RX and a TX line for transmit and receive. I believe that's what that is. Anyway. Getting back to the robot itself, let's talk about the power needs first. As long as I said that the brain and the encoder needs power, along with the motor needs power also from the Sabertooth. So I'm not going to go into this too deep because everything's going to be different, and they have in-depth instructions on the Sabertooth manual and the Kangaroo manual for all this stuff, and also the Easy B. But going into this kind of lightly, I'll try to keep it simple, is I have power coming in. This is where it all starts. I got power coming in to the Sabertooth, and I got this as 12 volts, and this is a 2-channel 32 amp Sabertooth. So that's 2 times 32 Sabertooth is what they call it. Pretty simple. Now 32 amps, that's pretty big. That little motor over there turning that dome, that brain and everything, radar, is only just a few amps. Why am I using such a big one? Because of something called regenerative power. Pardon me. This Sabertooth puts out regenerative power whenever something moves or breaks. For example, if that dome is moving back and forth, it's back feeding and creating regenerative power, which is by design because they want that. Their idea is to recharge the batteries as this thing is working. Well, I've got this on wall voltage, and I got batteries in there too, but it'll both recharge into the batteries, and when those batteries aren't available because it's switched over to the wall current, it needs something to dissipate that regenerative power. So this model of Sabertooth does that. There's something called a voltage clamp, and it can be designed for that. And this is a resistor right now. I found that 5 ohm 10 watt resistor, power resistor, is the way to go. That works just fine to absorb that regenerative power that comes back into here, and it's hooked up to a voltage clamp on this other side. So it's already set like that in the software when I get it, so I didn't have to go into there and change nothing. But that power output right there, that power port is set up right now for a voltage clamp. You can always set it. You can also set them up for extra power ports and other things. Again, I'm not getting into that. So what we have is power coming in, and I do not have this fused because Dimension Engineering says don't fuse these things, or else you could have a runaway condition if something fails or burns up. They said if you gotta fuse something, fuse the motor on the outside part of this coming out. So power coming in. Ignore that phone call. I'm going to. Power coming in. Regenerative power going out, being absorbed by this resistor. And once it gets the command from the Kangaroo to know what to do, the power comes out again at the proper speed, or PWM, which causes its speed. It comes up here, hooks into here, and you'll remember I have the top on here, and this in turn hooks into the power for the motor. So that's where that goes. Power motor power out from the Kangaroo. Now, the Kangaroo also, like I said, needs feedback from that motor so it knows what that motor is doing. So what happens is this connection has got the power going down to here to give that life, to give the encoder life. In turn, it reads where this dial is down here and how fast it's moving, and it sends the information out of the TX. I'm sorry, out of this transmit pin back down to this one, the encoder. And that goes into the wiring loom and comes out and attaches right there. Okay, so that's how the Kangaroo gets its feedback through these. And it's kind of cool because one of these pins is power and one is ground, giving the encoder some power so it can work, and the other two is transmit and receive. Now this is the serial connection coming in, and I send commands to the Kangaroo through the EZB and the attached software on the computer over serial. And that is, I don't know if you can see it right. Let me see here. It's that white connection right there. It plugs in there, and that's a ground there and a TX and RX, so it can transmit and receive commands. The EZB receives a command like, okay, go to position 130 at such a speed. Well, this sends that command down into this wiring loom, comes out here, hooks into the EZB, hooks into the Kangaroo, and the Kangaroo then knows, based on the information that's been getting from this, how far and how fast to send power through the Sabertooth back up here and down to the motor. So it's as simple as that. Okay, it's just getting everything wired in good. So for this thing to know though what's going on over there, when we first hook it up, it's got to go through a tuning routine, and that's all automatically done. You can either do it by pressing buttons on this Kangaroo, but I like to take it apart and hook it up to my computer. And they have Describe. It's called Describe. It's a software, and I can just take it apart right here at this Molex connector I put in, and through a TDL connection, I think it is, you hook it into the computer with a USB, and you hook the, you can see the Molex, I can plug that in, and you have your ground, transmit, and receive pins right there. So it's all wired up into that, whoops, it's all wired up into here through that Molex plug back there. So what I'm going to do now is cut away and plug this all up, hook it into my computer, and open up the program, the Describe software, and we will do an auto tune. Okay, be right back. Stay tuned, more to come. Okay, I am back, and I've got my Kangaroo Sabertooth hooked up to the computer now, and I've got the Describe software running that the Dimension Engineer gives us to interface with the Kangaroos and the Sabertooths. I went through all this before, so I'm not going to do that again, but what I've done is I've disconnected the serial input for the Kangaroo from the input I had coming from the EZB, the serial input, or the serial output, whatever you want to call it. Anyway, I've hooked it to a TDL. I think that's the proper terminology, to USB cable, and just make sure I had my ground and my RX and TX hooked up to the right spots. You can get these on Amazon. Plugged into USB here, and all I have to do, if everything is running good, is what I have to do is I have to connect to the Kangaroo. So if you see up here, you drop down, hook up the Kangaroo X2. This is an optional step because the software will figure it out on its own. And then I need to, and it switches over to the Kangaroo settings and software input, all the adjustments. Then I have to connect to the Kangaroo and download its settings right up here. Now, whenever I make a setting adjustment, I need to upload settings to the device. That'll be later. So right now I'm going to connect, and hopefully it'll give you this little thing. It should be set up already for you, but if not, do a little research and figure out the proper settings for your computer. Mine were already in here. Okay, and if everything's right, it should download the settings. Now, another little note here. Make sure all your connections are tight and right, because if there's any issues, it will not work. So you can also see, so I've already done a tune, okay, while I was away, and these were what some of the, and I've actually got it on the second channel, not the first. So this is the blank channel. So if it, reference in real time, that you remember this has got two channels to it. This is channel 1, this is channel 2. I've got everything hooked up to channel 2. We can put another motor to control over here, but I don't have that. Okay, coming back to anything you do now has to be, or I have to make the changes on channel 2. I've already done the one tune, so that's why you see something filled up here. filled in here. The other things that really matter is this tab here called Control, and you don't really want to mess with anything under the Advanced section unless you know what you're doing, so keep that quiet. And these are your over here, if you look over here, it says position deadband and speed deadband. These are the channels you want, these settings here are what you want to change to fix that, if you get some chatter or something. And the other one is the positioning. This is where you set all your limits. You got hard limits you can use, soft limits you can use, and that's basically your end stops. Okay, your endpoints. You can your hard limits are basically where your end stops are, your limit switches or whatever you're using, and your soft limits are maybe if you don't want to go all the way to the end and hit those stops, you can make it stop before it gets there. And this is just your normal travel. You have to have at least one of these and your normal travel filled in. You can also in this spot tell you about let's see, about how to set it up for starting and all that kind of stuff, limit switches, mechanical switches, that kind of thing. So anyway, then I'm not going to go into these other ones except for the live test. That's where you can actually, after you run a tune, you can go in to do a live position. Well, we're working on this on the channel 2, remember? Live position or speed, live speed. Let's not worry about these right now. But I always like to do any of my tunes right here in the software. I know that you can do it. The documentation says you can have your Kangaroo do it from push buttons on here and counting lights and stuff. You can see there's a light kind of pulsing back there, that orange light. It'll blink several times depending on how many times you push the thing and push the button, and then you get out of the way and let us do this thing. I like to do it here because it is more graphical. I can see what's going on, and I actually can make adjustments later on in the live position and live speed spots and get it tuned in easier. But right now, let's just do a tune, okay? And even though I've done a tune once, I can do as many tunes as I want. And it'll override the last tune you did. So remember, if you like the last tune you did, you don't want to screw nothing up, go up here to the, let me get this out of here. Once you get a tune that you like, that works, go up here to the file and just do save as. And you can save that, it's called a tooth file. You can see I've saved other ones here. You can save that last tune you did and you won't lose it. That's really important in case something goes wrong and you got to go back. Just that's a must. You got to do that. Tune, okay. You can see it gives you all sorts of information here that how we're set up, versions, and how fast it's going. Start off by going begin, of course, and it'll give you 3 choices of how you got to set up. You can, remember I said in the past video, you can either teach it with your hand, you can use limit switches or mechanical stops. Well, I've got mechanical stops in this one. It'll go until it hits that, bumps against that stop, and it knows where the endpoint is. So I'm going to choose that one. And remember, I don't have anything on channel 1, so take that out of the equation. Now channel 2. And this slider is so you can position it live. Let me see if I can do that here. Oh yeah, see? I'm dragging this back and forth. It's like an open loop. You can use that for getting it into the center. And I know from experience that is about the center right there for, let me get back just a little bit. That's the center right there for my mechanical stops, okay? It's not exactly straight vision-wise according to the robot, but that's where my mechanical stops are. So you always want to start your tune pretty much in the center, okay? So now once I click connect, it'll give me a few seconds to get everything out of the way because you don't want your hands in there. And then it'll start tuning. Okay, it'll say about to tune. So let's go up here and watch, okay? All right, there it is. He's having a nervous breakdown. You hit one stop, hit the other stop, boom, right there. Pay attention to the little kind of a jumping it's doing. See that kind of boom, 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 boom. That's not good. We'll go over that later. Okay, it's testing the positions and the speeds of the motor I have in there. It should be a nice smooth run, but it's not. It's kind of bouncing. Spoiler alert, that's because of some play I have. Okay. I was testing top speed there. Now it's going to the lowest speeds. Yeah, I got some slop in these gears. I'm going to have to go back and straighten out before I can get a good smooth tune. See that bumping? Boom, 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 boom. Okay, and it stops. We'll see what the computer says here. It says tune complete, reboot required. That means I'm gonna have to shut it off and turn it back on the robot, or the Sabertooth and Kangaroo. I had a successful tune, but I'm telling you, when I get back, you're going to see that I don't like the tune that it gave me. So we'll cover that in a minute. I'm going to turn this thing off for a second, and we will be back in a minute after I do the reboot. All right, I've rebooted, and everything's ready to give it a test to see if it worked. I'm still hooked up the way I was before. I am something I forgot to tell you though, and I didn't do, which is okay sometimes. It worked this time, but they want you to start off with a clean project. So before you do a tune, make sure you save it, remember, and then save it, and then go to open. Go to new up here, and you click that, and that'll wipe all your settings out that you put in there. And then you go to upload, and that'll upload a clean project into the Kangaroo, and you can start a tune from scratch. They say it's best to have not to have any kind of data preloaded into the Kangaroo before you do a tune. So save the old one, and then upload a new reset to defaults program, okay? And then upload that to the Kangaroo. So let's see what we did here. We'll go to live. Now that we have a tune made, let's go to live position. That's where what I always use. It'll ask you it's got an error to restart it. You know why it's doing that? Because we're on channel 1, remember? It's not going to let us do anything because we didn't tune nothing on channel 1. Our motor's on channel 2. So click that on there. And now it wants you to use the normal travel range. It'll also, and again, I got ahead of you guys. It'll want to home your. I'm using an encoder. It'll want to home your motor, so the motor's got to go to 0. So I'm going to do that now manually, just so you know what it looks like. So you start it up, it'll just go to one side like that. Boom, and now it's homed. And the computer knows where the encoder is. Okay, let's see if this will work now. Okay. Now you see if I can drag this up and down, and it tells you right where it's at. I mean, it does a lot of other things too. I'm not going to get into all that other stuff. This is where you want to, really quickly though, this is where you can do your fine adjustments. You can just keep it in the settings on these two buttons here, all tabs, input settings, and keep it at the all input tabs where the tune made its adjustments. Or you can click these buttons, will open up these two windows, and you can set your own speeds in there and your own positions in there, and see if it makes any difference or smooths things out. So we're not going to do, or you can just take everything off and just it'll go raw with the, whatever the motor wants. So you can see what this would look like. Let me get here and see, it's kind of wild. That's the motor just by itself. You can see how jerky and herky it is. Well, I'm going to unclick that, and we will stay with the limits that the tune set, and we'll see if that's any different. Well, it's a little bit nicer, but it's still got a kind of a jerk to it. You notice that? It's got better control. It's still got a jerk to it. Normally I'd try to balance that out in a couple different places. I'd go to the control setting, and I would adjust my deadband a little bit. You can watch it in that live test, and it'll tell you when it's in deadband. See up there on the top, it'll say it's in the deadband. If it's fighting to get in the deadband, that'll keep blinking on or off, or you'll get a lot of rocking. See, every time it's if it's in the deadband, that means it's good. If you're getting a lot of rocking and shuddering up there, that's probably because your deadband needs to be adjusted. Okay, another thing you can, I go to is I can, with the latest software in Dimension Engineering's described software, you can set what they call a speed limit or speed ramping. Okay, just leave the speed limit alone for now. That's only if you want to really, I don't know why it's on 2, but I'm always using potentiometer number 1. But if you want to slow down the speed, you use the potentiometer and set it here, okay? And then the speed ramping is a percentage of this. I found that maybe 75 to 90% is a good ratio from that. So if I bring this up to like 500, I'll notice it, okay? And the other thing that you might want to, this deadband here, this doesn't seem to do much. I can't see that it works very well. But the exponential gives you a softer curve. Well, I'm going to see how it curves. Whoops, that's, yeah, again, I'm on the wrong one. Over here. See how it changes the curve? And that makes it softer as you get towards the center. So anyway, again, if you make changes, make sure you upload right here to that. So now, I'll tell you what I think the problem is. I think the problem is in this thing that if you see this, see that play right there? I think that's what the tune is seeing. Every time it goes the other way, there's a little bit of play in there, and it adds that into its calculations. That's why you're seeing a jump all go around here. It should. I've got another Kangaroo and Sabertooth down here. And you see down here, this has hardly any play in it. So what I'm going to have to do is take this off. I'll turn this over and I'll tighten up those gears so they mesh better. And that should take a lot of that play out. And then I will run another tune and see if it makes any difference. After I do that, I'm sure I'm going to have to do a little bit of playing in the described software, but who knows. Okay, I'll be back and I'll show you how tight I can get those gears, okay? Be right back. Alright, I've got the collar off, the bubble section, and I'm looking inside the radar right now. And if you can see down in there, you see the teeth, how sloppy they are? I'm going to have to move those right down in there, all the way down to the bottom where the black is. You can see the teeth meshing. And I'm going to have to move this motor in about a 1/4 inch to get those to tighten up. But I've also noticed that if you can see right here, I've got some cracking going on. Those are scratches, I think. But around this bolt hole that I drilled, it's cracking. Over here, it's splitting and cracking too, and that's unfortunate. I'm going to have to fix that before I go any farther. I don't know if I'm going to be able to just get by with squirting some solvent in there to strengthen those up, or if I need to patch a whole new piece of acrylic on there, or just move the motor over to here, which would mean I'd also have to move my end stops and my physical stop back there. So okay, well, I got my work cut out for me here. I'm going to have to take all these bolts out here. If you can see that one right there, it's a screw. Stick a screwdriver down, take these bolts off, or these screws out. There's 4 of them, and then this whole top will come off and separate from the radar. So I'm going to do that. I'll be back in a little while when I got something to show you guys, okay? Hang in there. I simply pulled these screws out like I said I was going to do before. That's done. I'm ready to pull this up, get this out of here, and it comes right off. Okay, well, there we go. Now I have good access to that, and I can repair that all I want. Do whatever kind of modifications I want to do to that. So, alright, like I said before, I'll be back when I figure out what to do. I've got the motor taken out, and everything's kind of apparent what's going on here. Again, stress cracking. I don't know what caused that. Yeah, that little motor might have done it. I don't know. But what I've decided to do is I'm going to move the motor over to here. And you can see I've already done some measurements. I'm going to have to Dremel this out right here to give me some more depth, so that this will sit basically under here like this. I'm going to use that hole again there, drill out this hole back there, and it'll sit in farther, and everything should work good. I've made a bracket that'll aid me. I made this out of aluminum, and that'll pretty much sit in here. I still got to do some more trimming, and this will help stiffen that all up. I'm going to put this on the tripod really quick and be back in a second, and I will show you how it all goes together. Okay, I'm back. Again, this motor will sit into this hole right here. And this will sandwich over the top of it. And basically I think what's going to happen is this is actually going to go on top. I've got to cut that back a little bit more there, and that'll sit back in there. This will go up into here. This will clamp down and sandwich it all together, and when the gear's on, you can see I got to go in a little bit more. Anyway, once I cut that back, that'll shift back a little bit to hit this hole, and that hole there I've already got marked. You can see a little spot right there. I'm maybe going to make that a little bit of a slit hole so I can adjust it just a little bit. So that should give it all the firmness it needs, so this won't happen again. And I'll have plenty of acrylics back there to hold, and plenty of clamping action in here exerted. I'm actually going to maybe drill a couple more holes back here so I have a full clamp on it. I'm sorry, back here, so I can get a full clamp on it and just put 4 bolts in there. So we'll see. I'll be back and we'll see how it turns out. Okay, there's my fix. There's where it was mounted before. You see all the shatters, and I've moved it over here with that plate I showed you underneath it, clamped it down with the same stuff I used before, same bolts. I added a couple more bolts to the back here so it's nice and sturdy now. That is not going to go anywhere. That's what the bottom looks like. Okay, that should work. Alright, now this, I know this is just kind of rough, but putting the gear on there, it's just a dry fit. Lining up all the holes with the gear, roughly closely on center. And it shows me that I am really close. I still don't have the holes lined up quite right. So yeah, I think that's as close as I'm going to be able to get it. A little bit will probably help. Alright, I'm going to put this all together onto that, and then put it all back on top of the robot, and we'll do another tune. Having fun in the robot lab. Be right back. Well, after reassembling everything and running another auto tune, pardon me, on the Kangaroo, or with the Kangaroo, on that motor up there, with the radar installed, I still didn't like the tune the way it came out. It was jerky, herky-jerky, and it just wasn't the problem, I guess. But anyway, I'm glad I did that. I've got that all solid now, and it's not going to go nowhere. I'm glad I found that problem. So I dug deeper into the issue and took the gear set out of the radar and off the top of the collar, and I found the problem. The problem was that the gear set had shifted, and the cog, or the small gear, whatever was running loose on one side, and then when it got around to the other side, it was pushing tight, and it was hanging up and hard to turn. So I mean, the friction with everything together was just enough for everything to ride right until I got some torque on it when I was doing the quick turns back and forth on the radar. And then this, pardon me, this radar gear would shift just slightly and jam it up on one side, causing it to jerk and buck and stuff. So it's funny how that little Kangaroo senses that little bit of a change and adjusts for it. And this time it wasn't a good thing. So what I have done, I have rebuilt this a little bit. The big problem was it was causing the shift. Is you'll see over here, these holes are built for bigger bolts than I use. I think Greg wants you to use the number 10. I use the number 8 wood screw, I guess, sheet metal screw, because I have to, like I showed in the building of this thing in another video, I have to go down through that little bolt there, which is, I'm using that as a spacer, and it anchors down into the styrene, I guess this is, or plaster or whatever, and I have anchors under there that it screws into. So that's how I chose to anchor it with smaller screws than required. So I guess I caused this problem. So what I did is I shifted the main gear over a little bit, and I'm still using the original holes in a Lazy Susan, but I drilled the right kind of hole for this to come through, so I can just drill it through. And now, and what I also did is I carefully, after I masked up the joints and stuff, this will all come out. This masking tape will all come out. But I carefully got some 5-minute epoxy here, JB Weld 5-minute epoxy, and just gave it a nice light coat all the way around to help grab and hold this after I did a little sanding to rough the two surfaces up. And now, as I'm waiting now, I've got it clamped down so it'll be nice and tight and centered with the screws that I'm going to be using. And when the JB Weld sets in a few minutes, I'll take it all apart, I'll reassemble and get everything straight this time. And hopefully the next time I run a self-tune on the Kangaroo, that little motor there will run perfectly, and she won't bind up. Okay, I will be back. Keep your fingers crossed. Several days have passed, and I've done a lot of work since then. Found several problems, ran several different auto tunes, and each one would work to a point and then stop. Turns out that I found several problems in my build here. I think some of it was my engineering, the way I had it built, and a little bit of poor quality connectors and things. But really quick, I decided to do several things like separate the serial data lines and run them in a different way away from the power lines. They used to run back through here and down through here. I actually drilled a couple holes in my CSS here. This is for later use, so I could get the serial lines away from any kind of interference from power. Seems like I've read that some encoders, especially magnetic encoders, which I'm using here on this motor that I'm controlling, has an issue with the serial lines getting flooded with noise from power, and also if they have long runs, needing pull-up resistors. And that seemed to be the case here, because I got like 2.5 feet of from here all the way back up to the motor. That's the encoder feed right there. That's 2.5 feet. So I put right in here, I put a pull-up resistor, and it's really easy. I know it looks like a big mess right now, but if you look closely, I have 4 lines. I have the ground, which is green, then I have the A line, which is white. The center orangish wire is 5 volts going to the encoder to power it, and then the black one is the B line. So what I usually, to do a pull-up resistor, I got a 1K ohm resistor and just ran it from up in here, from the red to the black, and then from the red to the white. Two different resistors, and that gives the line a little bit more oomph, a little bit more voltage, a stronger signal. And I'll be darned if I didn't, after all doing that, I actually put on some better connectors here. I got a really nice tune that I really love. So it was a process of error. Again, a serial line coming over here that plugs into the top. I'm going to put this all together, and you guys will get to see how nice it is now. Okay, I will be right back. All right, I've got his head back on. I didn't put his torso on because that's not where I'm at right now. So you can see my other videos if you want to see anything about the torso. He is ready to go. I'm going to turn him on right now and let you listen to him. First thing he's going to do is he needs to find where his encoder is, so it's called homing. The script is going to home the encoder, then bring it back to 0. You'll also see the waist homing up to and coming back to center. I've also got it hooked up to the EZB that's in there. I took it off the computer describe software and I hooked it up to the EZB, so I now have computer control of him by writing scripts. And it's all through Wi-Fi back here to my laptop. I've written various scripts. It's getting bigger and bigger. Right now I am going to just hit the initiation script that'll do everything that I just said. It'll hook up the EZBs, and there's 3 of them in there, and start all the homing process. So it's all automatic. Okay, here goes. See, click, click, click. All right. Where are you going? It's not working. Oh no. Right now I'm going to hit the initiation button. I have scripts in there that animates everything for the startup so far that I have built. And you'll see the radar and the body actually home up and center. Okay, keep your fingers crossed. Here we go. First thing you're going to do is see the connection for the EZBs. And let's step back. Oh, there they go. You see the top going too? Okay. He's all centered up, and everything should be homed with the radar and the waist. Now, I just want to concentrate on the top right now. I have show you how nicely he's working. I got a few scripts here that'll go through different speeds. Okay, here's a very fast swing. A nice wrapping. Okay. Here's kind of a medium. And back to the center. And here's a slower one. I can make this crawl or any different speed I want. These are just 3 speeds I picked out. Here's a slower one. I can actually go slower than that, but those are the 3 that I picked out to show you guys. Pardon me. Okay, that's about it for this. I have already gone as far as I need to go with this video. There is one more thing I don't like. I think I mentioned before, I might have mentioned that the radar is noisy when it, see that? It's trying to stay centered, which is good. I'm going to shut the power down right now. Okay, it's off. And inside here, if you recall, there's a Lazy Susan with metal BBs. You hear them rolling in there? Sounds like Hot Wheel cars rolling around the floor. That's noisy. I don't like that. So what I'm going to do is on a different video, this video is going to be over now, but on a different video I'm going to take this all apart, take that Lazy Susan out of there, and I'm going to put acetyl BBs in there, acetyl bearings, which is a plastic, very high, very nice, self-lubricating, and being plastic, they'll be virtually quiet. So that's about it for this video. There's my head section and the radar and everything. So I hope you guys enjoyed it. I'll see you on the next one. Take care. Bye-bye.